Our planet is a world of dynamic systems, interconnected and ever-changing. These systems are in a constant state of flux, influencing each other in ways that are both subtle and profound. From the swirling ocean currents to the shifting atmospheric winds, every element plays a part in the grand symphony of Earth's climate. High above us, in the stratosphere, powerful forces are at work, shaping the weather we experience far below. The stratosphere, a layer of the atmosphere that extends from about 10 to 50 kilometers above the Earth's surface, is home to some of the most influential weather phenomena. Here, the air is thin, but the forces at play are mighty. One of these, a silent guardian of the poles, is the polar vortex. This massive, swirling system of cold air is a key player in the Earth's climate system, particularly in the polar regions. It acts as a barrier, containing the frigid air of the poles and preventing it from spilling into lower latitudes. This swirling mass of cold air, a colossal atmospheric cyclone, plays a crucial role in regulating Earth's climate, particularly during the winter months. The polar vortex is like a giant whirlpool in the sky, its powerful winds circling the poles and keeping the cold air contained. When it is strong, it acts as a fortress, holding back the icy air and maintaining a stable climate. The polar vortex is not a single entity, but rather two distinct vortices, one over the North Pole and its counterpart above the South Pole. These twin vortices are like the guardians of the poles, each playing a vital role in their respective hemispheres. They are similar in nature but operate independently, each influenced by the unique conditions of their regions. We'll focus on the northern vortex, a powerful force that influences weather patterns across the Northern Hemisphere. This vortex is particularly important because it affects the weather in many of the world's most populated areas. From North America to Europe and Asia, the northern polar vortex has a far-reaching impact. Imagine a spinning top, its base anchored at the pole, its influence extending outwards, impacting weather thousands of miles away. This analogy helps us understand how the polar vortex operates. Like a top, it spins with great force, and its influence can be felt far from its center. The stronger the spin, the more stable the weather patterns it creates. The polar vortex is not a constant presence. It ebbs and flows with the seasons, its strength waxing and waning in response to the changing temperatures. During the summer, when the temperature difference between the poles and the equator is smaller, the vortex weakens. But in the winter, when this temperature gradient is at its greatest, the vortex becomes a formidable force. It strengthens and weakens with the seasons, most powerful during the winter when the temperature difference between the poles and the equator is at its greatest. This seasonal variation is crucial for understanding the behavior of the polar vortex. In the winter, the stark contrast between the icy poles and the warmer equator creates the perfect conditions for a strong vortex. Its strength and stability are vital for maintaining normal weather patterns. A strong polar vortex means stable weather with cold air contained at the poles and milder conditions in the lower latitudes. This stability is essential for the predictable weather patterns that we rely on for agriculture, transportation, and daily life. But what happens when this guardian falters? When the polar vortex weakens, it can no longer contain the cold air, leading to dramatic changes in weather patterns. This disruption can cause extreme weather events such as severe cold snaps and unseasonal storms, affecting millions of people. What happens when the polar vortex weakens, allowing the bitter cold it contains to escape? This can lead to what is known as an Arctic blast, where frigid air from the poles surges into lower latitudes, bringing with it extreme cold and often severe winter weather. These events can have significant impacts, from disrupting transportation to straining energy supplies and even affecting health. Understanding the polar vortex and its behavior is crucial for predicting and preparing for these extreme weather events. Every winter, as the Northern Hemisphere tilts away from the sun, a fascinating and complex story begins to unfold high above us. This story is not just about the cold and snow we experience on the ground, but about the intricate dance of atmospheric forces that shape our winter weather. As the sun's energy weakens, temperatures plummet across vast regions, and the polar vortex awakens from its slumber. The polar vortex, a massive, swirling reservoir of frigid air, spins and churns above the Arctic, effectively trapping the most extreme cold within its icy embrace. This natural phenomenon is driven by the Earth's rotation and the stark temperature difference between the equator and the poles, creating a dynamic and powerful system. The greater the temperature difference, the stronger the vortex becomes, with its powerful winds acting as a barrier. These winds keep the frigid polar air locked away, preventing it from spilling southward and causing even more severe winter conditions. This is why winters in the Northern Hemisphere, while certainly cold, are generally bearable for most of us. The polar vortex, though unseen by the naked eye, plays a vital role in shaping our world and influencing our daily lives. It has a significant impact on the jet stream, a fast-flowing air current that snakes its way around the globe, steering weather systems like a river guides ships. A strong and stable polar vortex means a more predictable jet stream and consequently, more predictable weather patterns, which can make planning for winter weather much easier. But the polar vortex is not invincible. It is a dynamic system constantly changing and evolving. Like all natural systems, it is susceptible to change, sometimes with dramatic consequences that can affect weather patterns far beyond the Arctic. Recently, scientists have observed a disturbing trend, a weakening of the polar vortex, which has been linked to more frequent and extreme weather events across North America and other parts of the world. This weakening is believed to be connected to climate change, as rising global temperatures and melting polar ice caps disrupt the delicate balance of the polar vortex. Researchers are working tirelessly to understand these changes and predict their impacts, using advanced climate models and predictive technology. As we continue to study and adapt to these shifts, communities around the world are finding innovative solutions to cope with the increasing frequency of extreme weather events. By understanding the story of the polar vortex and its role in our climate, we can better prepare for the future and work towards a more sustainable and resilient world. And so, as winter gives way to spring, the story of the polar vortex continues, reminding us of the intricate and ever-changing nature of our planet's climate. On March 4, 2025, high above the Arctic, a dramatic event unfolded in the stratosphere, the atmospheric layer above where we live and experience weather. Temperatures, typically frigid at this altitude, soared dramatically in a phenomenon known as Sudden Stratospheric Warming, or SSW. Imagine a wave, not of water but of warmth, surging upwards, disrupting the delicate balance of the stratosphere. This sudden influx of energy, while invisible to the naked eye, had a profound impact on the polar vortex far below. The vortex, already weakened by other factors, began to falter, its once circular shape distorting, stretching, and in some cases, splitting apart. SSW events are not uncommon, occurring every few years. However, the event of March 4th was particularly intense, its impact on the polar vortex more pronounced than in recent history. This disruption, scientists warn, could have far-reaching consequences, unleashing a cascade of extreme weather events across the Northern Hemisphere. The weakening of the polar vortex triggered by the SSW meant that the Arctic air it had held captive was no longer bound. Like a dam breached, the frigid air began to spill southward, seeking escape from its polar prison. The polar vortex, once a symbol of stability, now faltered, its once circular shape contorting into an undulating wave. This dramatic shift in the polar vortex's behavior is not just a fleeting anomaly, it signifies a deeper, more concerning trend in our atmosphere. This wasn't just a dance of the atmosphere, it was a sign of a system in distress, a harbinger of unpredictable weather to come. Meteorologists and climate scientists have been closely monitoring these changes, noting that the once reliable patterns of the polar vortex are becoming increasingly erratic. As the vortex weakened, its grip on the Arctic air loosened. This loosening is not a simple process. It involves complex interactions between the stratosphere and the troposphere, leading to a cascade of atmospheric changes. The frigid air, no longer confined to the polar regions, began to migrate southward, spilling into lower latitudes like an overflowing ice chest. This migration of cold air can disrupt local weather patterns, leading to unexpected and severe weather events in regions that are typically more temperate. This southward surge of Arctic air is what brings the risk of extreme cold snaps to regions unaccustomed to such frigid temperatures. Cities that rarely see snow can suddenly find themselves blanketed in ice, causing disruptions to daily life and posing significant challenges to infrastructure and public safety. This destabilization of the polar vortex also has a profound impact on the jet stream. The jet stream, a fast-flowing ribbon of air high in the atmosphere, plays a crucial role in determining weather patterns across the globe. Imagine a river, its flow disrupted by a fallen tree. The water, once flowing smoothly, now twists and turns around the obstacle, creating eddies and unpredictable currents. Similarly, the jet stream, influenced by the weakened vortex, becomes wavier. its path more unpredictable. This waviness can lead to prolonged periods of extreme weather, as the jet stream's meandering path traps air masses in place. This can lead to prolonged periods of extreme weather, with cold air lingering in some areas while others experience unusual warmth. The contrast between these conditions can be stark, with one region enduring a deep freeze while another basks in unseasonable warmth. The weakening of the polar vortex is a stark reminder of the interconnectedness of our planet's systems. Changes in one part of the world can have far-reaching effects, influencing weather patterns thousands of miles away. What happens in the stratosphere doesn't stay in the stratosphere. The interactions between different layers of the atmosphere are complex and dynamic, with changes in one layer often triggering responses in another. It ripples outwards, impacting weather patterns, ecosystems, and ultimately, our lives. The effects of a weakened polar vortex can be seen in everything from disrupted growing seasons for farmers to increased heating costs for households. Understanding these changes is crucial for preparing for the future and mitigating the impacts of our changing climate.